All right, welcome back, everybody. I hope you're all doing fairly well, that everybody's staying healthy, and that we are keeping up with the material. As I mentioned in a couple of the announcements, if you can find a way to stay on track, even though we definitely don't have the same rigor schedule that we had before, it should really help as you're prepping for the exams. Procrastinating on these things can make life really challenging. So do your best to keep up with this and just know, since we don't have the activities that we usually have and we don't have those pauses for questions, that these lectures probably will be significantly less than the hour and 10, hour and 15 minutes that we typically take for the course. Doesn't mean the same content's not there, but we definitely will be getting to everything a little bit faster simply because of that lack of an interactive process. That means if you have questions, emailing me, asking those things via the office hours is really big. So let's get started on today's topic. All right. As we've been covering in our last couple classes, experimental studies have a ton of value to them. There is, however, when we talk about experimental studies, a lot of things that are required for them to be conducted. You do need some type of manipulation of some independent variable where you're splitting people up into groups. You need to be able to measure some type of dependent variable, comparing the measures of the dependent variable across the groups. And while doing so, find a way to control for any extraneous or third, or sometimes what we call confounding variables. This is not always something we can do in our studies, but that doesn't mean necessarily that if we don't have perfect control over manipulation or perfect control over those third variables, that we're at a loss and we can't conduct a study. It's just when we do those things, there are concerns and definitions that we want to talk about so we can understand all the nuances to these types of studies where we don't get the true experimental design. And that's what we're going to be focusing on in today's class. To do this, what I tend to like to do in previous semesters is have students come into groups and talk about some studies where they'd like to compare groups, but they wouldn't necessarily have control over who gets assigned into the independent variables. Typically, what this leads lots of groups to talking about is situations where maybe you just can't assign people to specific groups, either because they're pre-existing, you want to control gender groups, or people that chose different majors, or people that were in different other areas, or maybe just for ethical purposes, you can't necessarily assign people to groups. Right? You can't say, I'm going to randomly assign this child to a household that has lots of verbal abuse, or I'm going to randomly assign this person to a lifestyle where they have to smoke constantly. And because of those restrictions, because of the inability to do those things, what researchers are left with is kind of options for how to still talk about causation, or at least try to infer causation, but do it with kind of the mindfulness that because there isn't that control over everything in the independent variable, there are things that have to be kind of considered and hedged upon. Sorry for that. What this typically leads to then is two different types of studies. The first type is what we've kind of looked at before, but we're going to define lots of terms within it today, what's called a non-experimental comparison design study. Sometimes they're just called comparison research, other times they're called non-experimental studies, but the heart of these things is when we have studies where we'd like to compare two groups to each other, or three groups to each other, or however many groups to each other, but we don't have control over assignments or control over some really egregious, obvious extraneous variables that could be playing a role in what it is we're looking at. The other type of study we're going to be looking at is one we've actually alluded to a couple times before, but we're going to reiterate exactly what it means in today's class. It's these things called quasi-experimental studies, or maybe there is some type of manipulation, but maybe we don't have control over assignment, or maybe there is some extraneous variable out there that even though we're controlling assignment, we don't necessarily have the ability to control for that specific extraneous variable. Non-experimental studies are essentially a step beyond quasi-experimental research, where we know there's kind of a multitude of problems that might be playing a role in some of the differences that we're finding between groups. It doesn't mean, though, again, that if we have non-experimental studies or quasi-experimental studies that we can't run them. It's just we have to be mindful of what shortcomings are assigned to them. And also we have to be mindful of the language that we're supposed to use when talking about the research that we're conducting. So let's look at what are the things that these things can do for us and how they really are pretty similar to those experimental studies that we've talked about. Non-experimental studies and quasi-experimental studies are both doing roughly the same thing. Right? We're splitting up groups in this independent variable. It's just now the independent variable is something we can't necessarily either control assignment for, or again, we can't control for third variables on. We're measuring some second variable of interest that we're still probably going to call a dependent variable. Maybe we'll call it a quasi-dependent variable, and even some people say it's a second independent variable since we can't infer causation, but there's still some second variable that we're quantifying, that we're measuring, and then we're going to compare differences across however many groups we're comparing on that independent variable for this second dependent or again quasi-dependent variable that we're interested in. The big difference, though, when we talk about the groups and we talk about the comparisons is, as I've mentioned, that there's hedging and there's terms that we introduced when talking about the comparisons that we're going to do. And we're going to be breaking down all of these different things in some of the future slides here. One of the big terms that we're going to talk about a lot, and it's actually been alluded to if you read the slides a little bit more closely, is this term called non-equivalent groups. Many researchers who do comparison studies or quasi-experimental studies often call their groups non-equivalent groups. And this might lead you to ask, why are they doing that? Why are they talking about these groups already kind of inferring that they're not the same? It's not because of the treatments or the differences that they're encountering. What they're really saying when they discuss non-equivalent groups or use the term non-equivalent groups is that because they didn't have control over who was assigned into which group or who could be affected by the different manipulations differently, there's always a concern that some of the issues that they're finding, the differences that they're finding between their groups, might be already there or might have kind of come from other things that were undetected by the study design. Usually, it's not necessarily ethical issues that are at play, but sometimes you can see situations when people are comparing groups where inherent differences are very obvious that the researchers miss. Well, let's say, for example, I wanted to compare the hand-eye coordination of a group of individuals that just experienced a hurricane in Florida to those that hadn't experienced the hurricane in California. Well, maybe experiencing a hurricane doesn't have much of an impact on your hand-eye coordination, but if my Floridian group was the group that's pictured here, and my Californian group just so happened to be a group of Californians that I was able to recruit for my study, I might find a pretty dramatic difference in hand-eye coordination timing of the athletes that seem to be significantly younger in the California group than the Floridians. It doesn't, again, mean that I'm doing an extremely unethical study. It's just in that case, I've obviously not been able to control for some major third variables and maybe even some major differential effects in my study that really are at the heart of my non-equivalent group comparison. Most comparison studies, though, and again, most quasi-experimental studies don't get these huge, egregious non-equivalent group issues popping up. Instead, they're more minor. Right? What are the minor things that we can sometimes run into is situations where certain people just aren't available in one group versus another, or there's kind of an inherent issue that's underlying the differences between the groups that we can't control for. Well, let's say we're running a study where we want to look at the lives of children who grew up with families whose parents smoked versus children who grew up in families whose parents did not smoke. Well, there might be other third variables at play that maybe we can't control for. Maybe families who had smoking around in the house also were lower socioeconomic status families, or maybe alcohol was a more prominent thing in those families, or maybe there were other things at play that maybe impact performance on tests or physical ability skills or anything. with respect to those two groups that we're interested in. You can't really, again, control for who gets into what group. So even if a researcher is trying their best sometimes to control for very obvious, egregious factors like we see in the picture, in situations like the one we just spoke about, children and families of parents who smoked versus children and families of parents who didn't, might not be something that we could ever necessarily overcome. Same thing works with some of the effects that some of the manipulations might have on individuals. We again call this differential effects. This isn't about pre-existing differences between the groups as much as it is about how the two groups might respond to the manipulations differently. Maybe one particular group responds a little bit more robustly to a specific medication that they're given versus another group, and we just can't control for those robust differences because of some pre-existing difference that we didn't have control over in terms of assignment. Let's say we want to look at the different effects of, again, some type of training, and we're comparing the Californians to Floridians to each other. Well, those two groups that we just so happen to stumble upon might not respond to training the same way, right? The Californians might be very receptive to certain types of training, while the Floridians, in the example we have, might not be as receptive to that training. Obviously, there's also the underlying problem there of some pre-existing differences between the groups, but it could be even exacerbated by some of those differential effects that we're talking about. In essence, when you have non-equivalent groups, these are things that you're letting people know are potential problems. You usually try your best to control for these and measure whether or not these things are there. Sometimes it's very challenging. That's why we oftentimes cannot infer causation when we're doing these comparison studies, because we know we have these non-equivalent groups that could have some of these inherent problems associated with them. In terms of the types of non-equivalent designs that we can do, there are different names that are often given to some of the different comparison studies that we run. The classic comparison study is sometimes called the differential research design, and oftentimes it's actually just called a comparison study, where we're looking at two disparate groups and comparing them across some variable of interest, some dependent, or maybe we would call it quasi-dependent variable of interest. So maybe I want to look at the different GPAs between math majors and psych majors, or maybe I want to look at the hand-eye coordination of women versus men, or I want to look at the differences in terms of frustration responses of Cal State East Bay students to Berkeley City College students. Right? When I'm doing those comparisons, I'm not having any control over who gets into what group because these are pre-existing things. There's some second variable, some again what we call dependent or quasi-dependent variable that we'd like to compare them on, recognizing that we again are looking at non-equivalent groups, and whatever we find could be a byproduct of differential effects or some pre-existing difference that was already there. It can still be interesting, even if there are other factors at play, so we give it a special name and talk about it in that special way. But again, it's a very common type of non-equivalent design that you'll see researchers running. If we're looking at studies where we're comparing groups after some type of manipulation has occurred, usually this means somebody's experienced something pretty catastrophic or something that's kind of changed the way they might respond to something. We call this a post-test only design, where we're comparing groups to each other where one's experienced some type of manipulation while the other hasn't. Yeah, well, a classic example in psychology of a post-test design is if we want to look at, say, the mood of individuals after they've gone through some type of therapy versus those that hadn't. You don't often get to control who gets to go through certain types of therapy sessions, but you want to know the efficacy of that therapy so you can compare the overall happiness of levels who've gone through it versus those that haven't. And obviously with that, you can already recognize that there's a lot of assumptions at play. You're assuming there that the manipulation, the therapy is the only thing that's changing the differences between the groups, and that the groups went into that situation at the same level. You really don't know necessarily if that's the case, if you didn't have control over who was getting assigned into what group. This really leads to some potential pitfalls if maybe there is some type of an assignment bias underlying some of the differences that you're finding. Maybe certain people got chosen to be in that therapy group while others were not allowed to get into it. Or maybe, you're looking at people at the end of the therapy group that have gone through this arc and they're coming down from whatever their symptoms are versus those who are not necessarily in therapy yet that are kind of peaking or getting near the top of some of the symptoms that they may be struggling with. This is always a concern with these post-test only designs. It doesn't make them necessarily useless. It's just there's a lot of concern, trepidation that people often apply to reports when people talk about differences between groups after one group's gone through manipulation and another group, sometimes a control group, is kind of compared to that group that's experienced that manipulation. What some researchers do instead of running just these post-test only designs, if they have the foresight to be able to do it, is run what's called a pre-test post-test design, where you're actually measuring a group on whatever your dependent variable of interest is before they go through the experience, before they go through the manipulation, and then you're measuring that same exact group afterward. Honestly, if you're looking at the difference between a pre-test and post-test only design, I'm guessing you're already recognizing that this sounds a lot like the between versus within subjects comparisons that we've been talking about before. That's indeed the case. Essentially, a post-test only design is the equivalence of a between subjects design, and a pre-test post-test design is the equivalence of a within subjects design. The catch is with the pre-test post-test that makes it different from within subjects design is, again, we don't have very good control over assignment. We don't have very good control over who's going to be selected for the study in the first place. Essentially, we can measure a group before and after they've experienced things, but we don't know how representative that group is of the population as a whole. With that being said, there does have a lot more value, or there is a lot more value in that pre-test, post-test design versus the post-test only design, because you can control for a lot of extraneous variables, a lot of those third factors that could potentially be causing the differences that we find in a post-test only design. If you're looking for a non-equivalent design study that's kind of the one that most people strive for if they don't have control over manipulation and assignment, it's usually the pre-test, post-test design. Now, we're going to spend some more time talking about specific types of pre-test, post-test designs and some tweaks to them, some nuances that are out there that can give them even more value. But if you haven't taken a break right now, I encourage you, take 5 minutes off, pause the video, take a break. I'm going to do the same. And then when we come back, we'll break down the pre-test, post-test design and look at some applications to that specific approach. I'll see you all very soon. All right, welcome back, everybody. As I alluded to earlier, what we're going to be focusing most of our attention on in this last part of today's class are these things that we call the pre-test, post-test designs. Essentially, they're those within subjects designs that we alluded to last week that are more focused on looking at one group where we don't necessarily have perfect control over selection and perfect control over any of the potential third variables that might be out there that are impacting the group as we measure them before and after they experience some type of manipulation. The classic type of pre-test, post-test design is the one we talked about earlier. Sometimes it's often referred to as a one-group individual pre-test, post-test design. This is kind of the situations where we're looking at a group before and after without having multiple measurements of that specific group. There are, however, some situations where we're not just looking at one group before and after, but instead we're looking at a group or sometimes even a single individual. We're going to talk about this a little bit more in future classes when we talk about the single subject design. But in essence, what we're doing when we're looking at a group or single individual multiple times after is running what's now called a time series design. It's kind of a special type of pre-test, post-test design where Instead of just measuring again before and after, we're measuring a couple times before and maybe a couple times after. The classic example of a time series of design is the what's called interrupted time series events, where we're measuring the group before and after, even though sometimes there are specialized ones where we're measuring groups just once before and a bunch of times after, or maybe a couple times before and just one time after. All of these, though, it's important to note, are time series designs, and technically time series designs, again, are a type of pre-test, post-test design that's out there. Now, some of you might be asking, what is the point of these time series designs? What utility do they have? What makes them more valuable than the original pre-test, post-test design that we talked about earlier? Well, the big thing that these particular designs allow us to do is look for those third variables that might be playing a factor in some of the effects that we're finding. If you look at these three charts, you'll notice that in all three of these different situations, if I measured the group before and after, so in the very first line on the x-axis denoted by 1 and the sixth line denoted by 6, I would be able to assume, if those were the only two measurements I took, that all three situations had an effect. And if I didn't have any extra information, I would probably conclude that the manipulation I did was the source of that particular effect. But let's say instead of the situation choosing the upper left-hand corner, that I actually had a situation in the upper right-hand corner appear, where I measured a person a couple times, and whatever my dependent variable of interest was, and I found that their levels were fairly low to begin with, and then suddenly there was this huge spike right before I actually did the manipulation that I was going to do, denoted by that dash you see a little bit further to the right of where things actually popped up. Well, if I was running a time series design, I'd be able to identify that something obviously shifted levels before the manipulation was even at play. If I was just measuring the beginning and end, again, I wouldn't be able to catch that there was probably a third variable that I should be looking for that caused the change in the first place. Same thing with the picture on the bottom. If I'm seeing a slow, gradual increase across multiple measurements even before I do a manipulation, and then that gradual increase continues at the same pace, I'm probably getting an indicator that any effects that I'm looking at are not a byproduct of whatever manipulation I did, but instead a byproduct of something else, something underlying the changes that I'm seeing within the group. If we're looking at something that should prove that the manipulation works, it's the chart that you see in the upper left-hand corner. You see no changes in performance on whatever, again, this random dependent variable is. And then after the manipulation occurs, you see that dramatic quick shift. This is really valuable because it allows researchers to say, look, maybe I didn't have control over who was going to get manipulated. Maybe I didn't necessarily have the ability to concern myself with third variables that could be playing an underlying role in the differences. But I do know that there was no change in behavior before the manipulation, and then afterward, I saw a consistent trend that showed a pretty dramatic effect. Maybe still can't infer causation from this, but you can get a lot more comfortable with it. You can get a lot closer to the point where you can say, yeah, there's actually some causal thing probably at play here. In terms of other types of time series designs that are out there, the classic ways that this tends to be applied is not only through things like clinical studies or studies where we're looking at how different types of treatments might impact individuals. We also tend to look at this in terms of how things might change over time. Developmental psychologists have spent a lot of time not necessarily looking at how one particular thing impacts change in individuals, but how people just naturally change as they progress in age or across a specific span of their life. Now, this leads to a big comparison that's really important to understand when talking about developmental research designs. In essence, it can get at some key differences that might underlie some of the effects that we find in these time series designs. When researchers are just comparing groups to each other, what we would again call non-equivalent groups to each other, what they're doing in this research and developmental psych is running what's called a cross-sectional design. Maybe I want to compare 20-year-olds to 40-year-olds on some variable of interest. And those differences on that variable of interest that I find between those groups might be attributed to age. But again, there's other things that could possibly underlie the problem. What are the problems that often is tied to these cross-sectional designs and concerns that people always have are these things called cohort effects, group differences that are more attributed to the specific upbringing and environment that the groups were kind of raised in or found themselves in. And maybe the difference between 20-year-olds and 4-year-olds is not just their age, but some of the different challenges they encountered in childhood on a consistent basis. Some of the things that were going on in the environment as they were developing that shifted them in a way that maybe didn't shift the other group. That's, again, called a cohort. This is always a big issue with developmental research, so many people do choose to run instead the time series design where they're following a group for an extended period of time. But even these types of studies, which are called longitudinal studies, have their own litany of problems. One of the things that can pop up, much like we talked about before with the within subjects designs, is this issue with unequal attrition. Maybe in studies, if I'm looking at how things change over time, maybe one of the big issues that could be causing, or the catalyst behind the change, is people are dropping out at rates that aren't consistent and due to some other third variable. If I'm looking at the overall health of individuals as they age, I might find that you're actually pretty healthy as you age throughout life, but I'm missing the fact that, well, the reason why you keep seeing healthy aging in most individuals is because all of the people that get unhealthy or pass away were no longer participating in the study. It's not that we're staying consistently healthy, it's just the numbers are dwindling so that the overall health of each group stays somewhat consistent. These issues with unequal attrition are big problems for longitudinal designs. Another big issue for many researchers running these longitudinal designs is they are very time intensive and very costly to try to track people down for a considerable period of time. Most people usually try to run many developmental study projects in a span of a couple of years. Usually the cap is about 5 to 10 years where people can follow a group. It doesn't give you much leeway in terms of how much you can study across the lifespan. The lifespan's much more than the usual academic career in undergraduate or graduate studies. So how do we find a way to run something that kind of circumvents these cross-sectional design issues and longitudinal design issues? And one of the classic, I guess, solves for this is something that's called the cross-sectional longitudinal design. It's kind of a hybrid between the two different approaches, where you do measure multiple groups across different cohorts. So maybe you do measure 20-year-olds and 30-year-olds and 40-year-olds, but you don't just measure them once, you measure them multiple times, essentially running longitudinal designs for all of the different groups. And what this allows you the ability to do is kind of look at changes over life across these groups. So you can look for kind of consistencies in trends, but also changes that can control for some of the cohort effects that you're finding. It's kind of the best of both worlds because it avoids the issues with attrition, it avoids the cost issues, and it also avoids the cohort effects that kind of underlie the cross-sectional approaches that people have. There are some potential issues that can still arise with these, but these cross-sectional longitudinal designs have kind of become the gold standards for lots of developmental researchers. And that kind of gives you a sense of how we can take the basic premise of the comparison studies and these time series to studies and make them into something special. And this something special has really had lots of utility. There's lots of studies on aging that we've just been able to conduct over the last 20 to 30 years as a result of our improved ability of measuring change in this particular approach. And just to give you a sense of some of the things that are out there, I thought I'd let you watch a TED Talk, a very brief 10, 15-minute TED Talk, talking about healthy aging and certain things that you can do and certain things that seem to be at least indicated by some of the science that people have been running that usually reflects these cross-sectional longitudinal designs. Now, the researcher presenting the information will not necessarily reference this particular approach too often, But you can appreciate that most of his research did actually come about through this approach. And I think if you look online and other places more, you'll find even more information kind of confirming the utility of this particular approach to research. This is where we're going to kind of close out with what we're going to talk about today. It's really important, though, when we do that, to reiterate that what we're looking at here is really not that far off from what we were talking about in our previous classes. Right? Both quasi and non-experimental comparison designs, all the different iterations of it, still doing the same thing as our between and within subjects designs that we talked about before. Catching information on some independent-ish like variable, and we're collecting information on some dependent-ish like variable. And we're comparing the groups or the levels of that independent-ish variable across that dependent-ish variable so we can see where the differences lie between those groups. In your stats classes, you're going to learn that you're going to run things like t-tests and f-tests and other things the exact same way in these designs as you would if you were running a true experimental design. The key element here is that if you need to be a good researcher and recognize what type of design you have so you can talk about your results correctly. Inferring causation, not talking about the potential pitfalls of third variables or extraneous variables is really dangerous when you're running these types of designs. If you can keep the concepts in mind, the terminology in mind, not only can you maybe help yourself, but you can help others listening to you really get a better grasp of the kind of implications behind the research that you're running. There are differences between these, right? There's terms that are different, and there's issues with causation. So I want you to recognize that we're not just reiterating the same stuff we've covered before, but if you can chart out the connection between what we looked at today and what we've looked at in our previous week, you're in a really good place, a place that many graduate students and faculty members sometimes forget about when they're looking at the utility and the application of their research that they've conducted. That's going to mark the end of what we're doing today. In our next class, what we're going to do is actually transition to another type of research that many researchers conduct, where we're not necessarily comparing groups, but now we're looking at how well 2 or 3 or more variables go together. In essence, we're going to be talking about something called correlation studies. So I'll see you all in our next class via this medium. I hope you all again stay safe, stay healthy, and I'll be hopefully seeing you soon. Not too soon though, because I'm hoping you're not cramming, but I'll see you soon. Take care.